Welcome to episode 4 of the Java with AI series. In this episode, we'll go over how to make our projects completely free of any bugs or issues, making use of unit tests to test various methods inside of our code. So before we start learning how to use AI to generate unit tests, it's important to know what unit testing actually is. So it's essentially just an automated inspection service, but for our code. So a separate script has these unit tests, which run various methods in our main project by testing them with various different inputs to make sure all of the calculations made inside those methods and actions taken in those methods work correctly. So unit tests are really important, especially in large projects, but developers often skip writing unit tests because it's a really tedious process that involves coming up with multiple test cases for each method, which can take a lot of time away from actually building the project. However, Windsurf can actually generate these test cases automatically for us, so we don't have to spend as much time actually writing the test cases ourselves. So before we start creating any test cases, let's actually create a sample method to actually create the test cases for. So for example, we could create a function or method that just calculates a discount for a specific price at a store, and then depending on whether they have a membership card or not, or how large the price is, then a different discount will be applied, and then the method will return the discounted price. So first we can create a method signature. So it'll return a double for the price. And then we can call it apply discount. And so the first argument will be price, but we'll actually be calculating the discount in the method. So instead of giving another double discount, we can give boolean has member card. And then firstly, we have to check for edge cases here. So if the price is less than 0, or it's negative, in other words, then we have to return an error saying the price cannot be negative. So let's first check for that. And then it suggests some extra code to us. Windsurf's inline completion, auto completion. So it already generates the error message for us, and then checks if they have a member card. And we can even make this discount slightly higher, maybe a 20% discount. And then otherwise, maybe we'll give a discount if like the price, say, is greater than $100 to promote large spending. And so that's exactly what the AI predicted here. And then what we can do is give a 10% discount for that. And then otherwise, we can just return the price as it is, because no discount needs to be applied there. So now we're done creating the method we want to test, so we can actually start generating the unit tests now. So we can go to Windsurf Chat and then use to focus on the apply discount method. And then we'll ask Windsurf to create let's say 5 JUnit version 6. JUnit version 6 is actually the tool that we'll use to execute these unit tests and make sure the method runs properly and performs the correct calculations. So we wanted to create 5 JUnit version 6 tests, and then we want the tests to cover multiple different scenarios, not just usual ones that most people would test this method against. We want multiple different scenarios to ensure that this method can perform the correct calculations no matter what. So we want to make sure these tests cover standard scenarios and then cases with varying membership status, so that has member card can take in either true or false. It could be random depending on the specific unit test. And then finally, we also want to cover edge cases like negative prices. So now we can send this message. And so now you can see it's generated 5 different unit tests here. And so firstly, it calculates the result that's returned by the applied discount method, and then it either asserts it as equal to a specific value, or it checks if it throws an exception or an error. And so now we can copy this over to a new class calculator test. So now we can paste it in. And so now you can see there's a lot of red underlines below a lot of text inside the code here. But that's because we haven't actually installed our testing library JUnit yet. So to install it, what we can do is find the beaker icon in this left-hand sidebar here, and then we can click Enable Java Tests, select the recommended option, JUnit Jupyter 6, and then you can see the test libraries have been downloaded. And so now you can see it's detected that calculator test is a test file here. So we can now run the tests, and then we can check whether each of these method calls, which have just loaded in, actually function or not. And so we can run the test, run all the tests, and then you can see there's some problems that we have inside of our folder here. There are some red highlighted errors in some of these files as well. So to actually run the tests, no files in this directory have to have errors, so we can just temporarily comment this code out by highlighting it and pressing Control/. And now we can rerun the tests. We should be able to now. So if we run the tests, you can see all the tests are green here, which means all of the tests are now actually working. All of these various sets of arguments actually produce the correct output, which is great. So I just stopped the tests just now, making use of that big square that said stop as the tooltip. And you can see 6 out of 6 tests were successful, which is great. However, there are cases when Windsurf generates the tests that there are some errors that come inside of the test file. So here's the code inside an earlier response that I got from Windsurf when I asked it to generate the tests. So you can see there's actually an error inside of this testing file. It says assert throws is undefined for the type calculator test. So what we can actually do to fix this error is actually go back into Windsurf and ask it why this error is actually present. So you could say, I have an error in this testing file, and then we can hover over this tooltip here, copy the error message, and then click send. And then it says, to fix this issue, we have to import another class up at the top here, and then import the assert throws method from that class. That's the line up at the top here. And now you can see there's no error with the assert throws here. So well, all we have to do to fix it was actually just import it. So it's saying make sure you have the following import statement at the top of your file. This should resolve the error. And so now if we run this testing file here, then you can actually see some of the tests fail. So it appears that a lot of the logic here is actually incorrect. So if it has if the user has a membership card, then they should get a 20% discount, but it didn't account for that in this test here. So what we can actually do is ask Windsurf something else. We can say, the no member card test and price below 100 test failed. And then we could tell it to find the reason behind these failures and fix it if possible. So this is how we actually find a solution to this problem. And so now it finds out that the expected discount values are incorrect. So for the no member card one, the expected discount has to be changed. So we can actually prove that the tests are working. So at first glance here, it doesn't actually look like Windsurf has even changed anything, but we can rerun the tests to double check. And sure enough, the same 2 tests failed. So we can say the 2 tests still don't work. You haven't actually changed any of the expected discounts. And so now you can see that these discounts still haven't been changed. they're still the incorrect values. So in this case, you can actually do a lookup of the whole code base by pressing Control Enter when sending a message. So we can ask the AI to look at calculator.java to double check how the method works and actually provide the correct expected discounts and to not leave them as they are. And so now we can click this button at the bottom here to make it check the whole code base. And so now you can see it's actually changed the expected discounts. So for the standard scenario, the expected discount is 20. That's the exact same as before. For the no member card, actually it's given all of the updated tests here, so we can actually replace all of them. So now if we were to run the tests, you can see these same two tests aren't working. So this is the case where we just have to step in ourselves and fix it on our own. So let's first look at the no member card test. So the price is 100 and has member card is false. So now that means this 20% discount isn't applied. 100 isn't greater than 100, so this 10% discount isn't applied. So it's just the normal price, meaning the expected discount is actually 0 here. And so now let's look at the price below 100 test. So the price is $50 and has member card is true. So it immediately knows this condition is true and returns a 20% discount. And 20% of 50 is $10. So that's the expected discount, not 0. So now we can rerun the tests because we're done fixing all the broken ones. And we should see it marked this test as still failed, but that's because we have to actually subtract the expected discount from the price. That's something we forgot to do. So now if we run the tests, you can see they all function correctly. So this is just a case where Windsurf was actually stubborn to change any code, and we had to step in ourselves. So it's actually a good thing to know that this can happen, because now we know that we can actually step in and make changes to the code when we see fit. The AI isn't just doing all the heavy lifting for us. So now here's the challenge to cap off this episode. So what you want to do is take the isPrime method that I put in the video description and ask Windsurf to create 3 unit tests for it, testing the function with various different numbers. So there is a chance that Windsurf will act up and refuse to fix any errors with the tests. So in that case, feel free to manually step in to fix the code that it generated. Thank you very much for watching. Like and subscribe if you enjoyed the video. And make sure to look out for the final episode of the Java with AI series, where we'll learn how to build an app 10 times faster making use of AI.